Appreciate everyone joining in. My name is Don Milstein. I'm president of H2O Degree, and I also have Troy Llewellyn on the line. He's our head of our technical services.
How you guys doing?
There we go. And, really we're going to focus this presentation on thermostat controls and what they can be used for a multifamily property. We can also discuss commercial or institutional properties also as we go through if anybody has questions. What we do, we typically, the mics are open if you want to ask, or you can use the chat. So don't be afraid. Right now it's not a huge group, so we're able to manage through that. But I'll definitely stop as we go through this a few times. Some contact information up here. A gives you email address. I think at the end we have the phone numbers. And then, aside president of H2O Degree, I'm also chairman of what's called the Utility Management Conservation Association. And that really looks at the rules and regulation around billing tenants for water, electric, and gas, as well as energy conservation opportunities in that industry, such as thermostats. So just keep that in mind if you got any questions on, any of that regulatory side throughout the U.S. and into Canada. We can, if I can't answer, we can definitely get the association to help out with that. So just, want to give you a quick overview as we lead into the thermostat. So H2O Degree really focuses on 2 to 3 areas. The first being tenant billing for water, electric, gas, BTUs in multifamily, right? So whether it's an electric meter going into each apartment or a water meter doing the whole apartment or down to an individual toilet, it really doesn't matter. We can look at any type of multifamily unit and determine the best way to meter it, and then send that data either to the property owner or to a third-party meter reading and billing company, which is now going to do that billing. So that's a big part of our business, is just using the data for billing. And we'll also talk about how you can use the thermostats to give you what's called runtime to do billing. So that all falls into that first left-hand corner. The second area we focus on is what we call leak detection, which is wasted water down the drain. So it's either the toilet's running or water's going down the sink or down the shower drain. So that's leak detection. We do a whole reporting for that. The other area is flood detection. We differentiate flood being water on the floor that could cause physical damage. And all this we bring back into reports and alarms, and everything we've talked about is all wireless throughout the property. The third major area is what we're going to highlight today is thermostat controls. And this is how you can go and use thermostats in apartments to not only save energy, but also do some controls and look at maintenance issues and even do billing. The whole goal here is, from a property owner's perspective, is how do they reduce their operating expense? How do they lower their costs for utilities? And by lowering the costs, they increase what we call net operating income. This is really the profitability of the business. So if they can reduce utility costs by $100,000, great. They just saved $100,000. So they have increased cash flow, and they increase their net operating income, makes them more profitable. The one unique aspect in any of these properties is that the value of the building itself is based on their net operating income. So they bought this system, it saved them $100,000, great. Payback in a year, 2 years, something like that. But the value of their property took that $100,000 and pretty much, in real estate terms, to use a capitalization rate, the value of that property went up 10 times that. So the property was now worth $1 million that they can either take a loan against, or when they sell the building, they'll make money off of that. So kind of interesting dynamic that we're not only looking to save income this year, but also boost the property value for the long term. And just for a half a second, H2O Degree really in its present form since 2007. Over 190,000 wireless meters and sensors are installed throughout the U.S., over 30 states. Principally has been in apartments, as you can see, over 1,000 properties, 90,000 units, but doing more and more in the commercial and municipality, institutional type industry also. And our buildings go anywhere from typical apartments in the U.S. is probably about 200 units, so we go down to 25 unit properties and as high as 1,000 unit property. We can show you some examples of that at the end. Both big and small as far as ownership groups, either real estate investment trusts, some of your big public companies like Aimco and Avalon Bay, some of your more private companies, big ones like LaFrac, or just 3 guys that own a 100-unit apartment complex. Do a fair amount in schools, universities, and affordable housing as well, which is both at a state level, New York Housing Authority, or HUD housing. And again, when we talk about multifamily, we're talking about apartments, condos, co-ops, mobile homes. These are some of the areas. Student housing is a big one, low income, even get into the military housing. Hotels, I'm not quite sure that falls under multifamily, but it's definitely the same type of atmosphere. And then I guess we also have water, electric, and gas that we get involved in. All right. So let me just stop there. Any quick questions on H2O degree or what we're going to get ready to present? Just feel free to open your mic, or if you have anything specific you want to hear about, I'd be happy as we go through this. Give everyone a second. All right. So when we talk about thermostat control, it's a little mix. It's an actual thermostat, which you can see there on the right-hand side. We call that the T1000. But at the same time, every one of those thermostats we're talking to wirelessly throughout the building and setting up controls. And the goal is to ultimately reduce the heating and cooling bills by 10 to 20%. And reality says for every degree you can reduce, you'll save about 2 to 3% off your utility bill. So it doesn't take long to be able to put in some controls to kind of shoot your average down 3 to 4 degrees and get those type savings. And we look at it both from the property manager's perspective as well as the tenant. And what we're doing is we're going in, and you can put in these thermostats into the building in a wireless network. And when we say wireless, we're not talking Wi-Fi. We're talking our own, what's called Zigbee network, so 2.4 gigahertz network. So we're not really interfering at all with what is going on in each apartment. It's our own network that the ownership group has control of. And they can go in and set the set points and tell that thermostat you never go above 74, you never go below 68. Or give the tenant full access. It depends. If you're in a market rate apartment and they're paying for their heating and air conditioning, you're going to give them full access. But if it's maybe it's a student housing or some kind of affordable housing, whether it's a Section 8 or a LIHTC, low-income tax credit type property, or a housing authority, the owner's paying all the whole bill. And at that point, they're going to put in some controls. Not above 74, not below 68. 10 o'clock at night, set back the thermostat 2 degrees. If somebody wants more heat, they got to get out of bed to get it. They can still have it, but we know the normal trends, and we work with each individual owner on setting some of that. Can get involved in demand response. A big area of savings is vacant apartment mode. We'll talk a little more about that, but when an apartment's vacant, those settings will be a lot different because no one's going to be in there. And then we can also use the thermostat, as I mentioned, for runtime. And what that means is you might have some centrally heated system, and you want to go and allocate costs of how long they've been calling for heat or air, and charge them for that. It's the only real way to do that when you have a centrally heated system. So using the thermostat to give you the actual runtime, calculate the BTUs that are being used for the whole building, and now charging each tenant. Pretty unique way to do that. From a tenant perspective, the tenant has control, but it's within the property manager's set points. So the tenant can go up to the thermostat, turn it up and down, but it's only going to go within a parameter set by the management team. They can use a mobile app. They can go into the portal. So they feel good that they're engaged with this thermostat. But it also gives a lot of maintenance reporting. And this is an area I want to kind of focus on is, hey, it's 30 degrees outside. I've been calling for heat all day, and I can't get the apartment above 50. Well, that's an indication of a problem. And like I said, the goal here is to put in some thermostat controls and save 2% for every degree, which really adds up. And at the end, we'll show you, I don't know, half a dozen projects with thermostats, all different types. That'll kind of explain that. So again, when we think about target markets, we obviously going into market rate, your normal market, normal rentals. But a lot of savings come in those first 2 or 3: affordable housing, student housing, military, and assisted living. In those cases, the ownership group is paying for the air conditioning and heating and is able to put in controls. So that's where there's a big opportunity that we've seen. The first part of using a system is for conservation. Again, control limits is a big area, right? Just not above a certain amount, not below. Vacant costs is one of the highest costs in a property. In some cases, their utility bills could be, even if they have a 95% occupancy rate or 97% occupancy rate, those vacants could be as much as 10% of their bill. And what happens there, as soon as the tenant moves out, let's say they move out, and what's today, September 26th, it's 80 degrees outside. Maintenance guy goes up there with a bucket of paint, walks into the apartment, hits the button down to 65 degrees, paints, and leaves. And now it stays at 65 degrees until it's rented out. And that could be a month, it could be 2 months, who knows. With this system, as soon as they give you back the key, you turn it into a vacant mode. And now that thermostat never goes above, maybe it stays in that 72 to 75 degree range. Or maybe it's set for 75 and above. And the maintenance team can go in, move it to 72, but it only stays at 72 for 2 hours and then comes back. Another big deal with vacant mode is you don't want it to be where a tenant moves out and someone leaves that thermostat at 80 degrees in the summer, not providing any cooling. You're like, okay, I'm losing money by cooling, yes, but you're also preventing any kind of moisture or mold type buildup. So you want to keep some temperature controls there. You also have opportunities when tenants are on a vacation, or if you're in a student housing, maybe there's a holiday schedule or spring break mode when they're out for a week, or the summer mode. And we have a slide a little later that talks about that in more detail. We talked about the runtime to build these tenants if it's essentially heated and cooling system. Then you even can participate in demand response initiatives. Demand response in your local market might say, hey, if you can turn off the air or raise it 2 degrees in the summer when we have a blackout mode, you can get some incentives back. And with this system, you can do that because you can hit a button at that time or set it up automatically to go ahead and shut down every thermostat or raise every thermostat 2 degrees automatically across the board. You can even pick and choose. Maybe I'll just do half the building now and half the building later, or some combination thereof. The other area that the systems use is for maintenance. And this is kind of interesting when you think about how do I get some control here from a maintenance standpoint. We never might have achieved the set point. 85 degrees outside. I've been calling for air conditioning all day, and the apartment's still at 80 degrees. Never got to 72. That's an indication your air conditioning unit didn't work. Same for the heating side, right? It's 32 degrees outside, and we bring in outside temperature into our software. So we know what the outside temperature, we know what the room temperature is because we get that directly from the thermostat. And we know it's been 32 degrees out. They've been calling for heat all day long because they set the thermostat to 72, but inside the apartment never got above 50. It tells us there's some problem with the heating system, and now it goes out as a maintenance report for the maintenance team to go target which apartments to go fix. We can see if the air conditioning cycling on and off or the heating is on and off, because we can see a little waveform showing that in the agreement. And if it goes up and down too many times, we can send out a notice to do that. We can see it's been running nonstop, never off. We match that up with outdoor temperatures and set out a separate report. It also gives you the ability to do some benchmarking. How do we compare this tenant versus this tenant versus that tenant? Right? They're all the same size apartment, they're all one bedrooms, but one's using twice as much heating or air conditioning. Could be some other issue in that building. Or it's the tenant themselves and we need to go address with them. They keep their window open all the time, but they'll put the heat on the whole time. Doesn't make sense. And then you have the system that'll give you charts that'll graph not only the indoor temperature, but the outdoor temperature. And I'll show you that a little later. And this is very helpful when a tenant calls up and complains. And, I pick on Mrs. Smith calls up. It's in the winter time and she's, calls up, she's freezing. Yet her apartment's been at 74 degrees every day, every hour. And sorry, Mrs. Smith, you got to put on a sweater. I mean, we're providing you reasonable amount of heat. We're always in compliance with whatever each individual city or state has some kind of codes. New York has a whole thing that, if you feel like you're not given enough heat or air conditioning, you call 311. You can set out a formal complaint. Just an example, but this alleviates that. You can show them the graphs, and it really protects you as a building owner. The next one is kind of very interesting. This is what's called safety and catastrophes. And what this is doing is something you wouldn't think about from a thermostat control, but as soon as you have the ability to alarm for different events, you have this ability. So let's take the winter time. It's 32 degrees outside. The thermostat's set for 72 degrees and never supposed to go above that. Yet the apartment reads 85 degrees. So mathematically, that's not possible, right? It's 35 outside. I set it for 72. How did I get above that? Well, that's an indication of some kind of external heat source. I might have a space heater, kerosene heater. I got the oven open, right? People have done all that. And they're doing that because they want more heat, but don't want to pay for it, or they can't get enough heat out of the thermostat system. The first thing it does, it violates the lease. Most leases say you can't have space heaters, but it's also a huge fire hazard. And unfortunately, we've seen this in the news last winter in the Bronx when they had that big fire in affordable housing. I'm not sitting here saying we could prevent that, but we could have given an early indication of, hey, somebody has an external heat source used regularly in that apartment complex, and which apartment. So that's one. In the wintertime, if they have the heat too low, maybe they went on vacation, just turned it down so they never have to pay for anything. Right? They're down in Florida, they're a snowbird. Well, that's not good either, because if you keep it too low, you might have pipes freezing. So we always want to understand that we never want that radical swing in temperature. So we might set up an alarm that says, hey, if the temperature in the apartment is below 50 degrees, 55 degrees, send an alarm, because we got to go up there and put some heat on and make sure we don't have any kind of freezing pipes. In the summertime, it's the opposite. The temperature's too high. It's too hot in the apartment, especially in Florida. We run into this, where they want the air conditioning, even if the person's not there, to always maintain some level of air conditioning because they want to prevent mold. And then the last one is that code violation. Right? Each city, especially for affordable housing, says, hey, as a landlord, you must provide X heat or X cooling during this time of the year, and here's the dates, and here's the amount, and this keeps you in compliance and also helps if there's any kind of complaint to deal with it. So a unique added feature when you put in an internet-enabled wireless thermostat control system, which is what you have, right? So you're able to read it remotely all the time, alarm all the time, throughout the system, and it really gives you that advantage of not only controlling it to save energy and look for maintenance issue, but to prevent some of these events happening. I want to turn it over to Troy for a minute to kind of go over the types of systems we can use the thermostats for, and then we'll stop and see if there's any questions. So, Troy, if you kind of get a little description of each one as you go through. Thank you.
Thanks. Thanks, Don. Can you guys hear me?
You're good.
Okay, gotcha. Yeah, so just a few of the systems that we can use on the T1000 here, not only for energy conservation, but any tenant billing for heating or cooling runtime. So the first being furnace, whether that's straight heat, heating and cooling, what we call a split system, boilers, hydronic zone valve systems, heat pumps, with or without electric or auxiliary emergency heat backup, electric baseboard systems, utilizing a wireless relay for heating, again, straight AC, whether that's a air handler with just air conditioning, again, hydronic systems, anything zone valve related, and then PTAC, so packaged terminal air conditioning units. You probably see them a lot in hotels, but we do see them a lot in multifamily apartments or senior housing. So a lot of different applications.
So I think the key part here is, other than steam, I think pretty much we can control any kind of heating and air conditioning with one of our systems, whether it's full control or just on and off control with a relay. And we'll show you one of those type projects. Suffice to say, there's nothing we can't handle. And our team here, which Troy heads up, can look at the drawings, lay out the job, help you with that, whether you're a engineer, a contractor, or the owner themselves. We can deal with all those at the same level and give you support. And one piece of this, all of this thermostat control can also tie in with what we showed you on the first slide, which were the meters to do billing, or the toilet meters for leak detection, thermostat, and for flood detection and shutting off water if there's a valve. So it's one of those type systems that you can start with just thermostats and then grow, or do everything at once. Really allows you that flexibility. All right, any questions to this point? All right. So I want to spend a minute on two unique applications, school universities, and then we'll talk about some hotels. So school universities, if they do bill the tenants, which a lot do and some don't, for whether it's water, electric, gas, or heating, it's really done on a per bed basis, because most of these student housing has at least two people living in a dorm, but sometimes there's three or four, or a lot of movement is now with kind of a suite view, almost like an apartment style living in the student housing, where there's 4 bedrooms and common area. So they want to be able to build that air conditioning and heating to those students. Again, they put in a vacant mode for when the students are not there. Totally different set of parameters that the apartment would be set. But the other major difference in schools and universities is you have a lot of long-term breaks where they're not there. So when you have winter break, you might be out for 4 weeks. So you want that as a totally different setting than when it's occupied. And then in the spring break mode, depends where it's located. If it's down south, they're going to have a totally different reading than up north. But either way, it should not be at the same level throughout the property. And all this can be set up in the software, automatically done. You're not going to rely on the students to be doing it, turning it on and off. And you're not sending your maintenance people around to each apartment or each dorm room to make the change. And then summer mode's the same. Maintenance issues is a big deal in schools and universities, because the kids for the most part just don't care. So you want to be able to get ahead of it. You want to get those alerts before it becomes a major issue, and really before mom and dad have to call you, which you never want. And then all this can integrate with the toilet leak detection system, which is a great avenue, right? We love doing schools and universities where we're putting a thermostat in each apartment. a meter on each toilet, and we're going to save 20% off the utility costs by fixing leaks or giving you notices of leaks in the toilet and getting a couple degree savings on the HVAC. So that's in a school and university type environment. When you think about a hotel, again, it's 200 room hotel where they want to put a thermostat in each one. Control that down at the front desk. Put it to vacant mode, so as soon as the tenant gives you the key to move out, or the guest, it goes to vacant mode, which might be 74 to 80 degree setting, and then once the guest comes into the front door and starts to check in, the front desk can automatically switch that system over to cool or heat, depending on what the need is. But a big area here is a lot of times those rooms are not occupied. I mean, they're being paid for, but no one's in there. And when that happens, you want to understand maintenance issues because they're not always being reported. And you want to understand if you had a leaky toilet because no one's listening for it and no one's being bothered. And any of those maintenance and toilet issues, when you do get a call at the front desk, it's always at 12 o'clock at night, 1 in the morning, and someone can't sleep because it's too hot or to hear the toilet running, and that's very costly to go fix. So what we've done here with these maintenance type modes is really to help, we're not trying to change the behavior of the tenant or the guest in the room, but we're changing management's behavior and being proactive in fixing problems, right? Getting the maintenance teams to get a list of the issues with the air conditioner heating or issues with the toilets and getting out there fixing those. So we get proactive at it. So that is, a couple of things looking unique at in a hotel room. All of this not only is a physical thermostat in the room or in the whole apartment, but the ability to view the data and get alarms online or through a mobile app. Again, we're going to give you graphs showing you the usage, showing it both inside temperature and outside temperature. You'll be able to identify which tenants are using more. It can even alarm for that. You can track the heating and cooling down to each individual apartment, set the set points, and pick and choose which apartments. You can do globally, everybody's 68 to 72, or you can say, wait a second, I know the west side of the building gets a lot hotter or it's right above the boilers, so I'm going to put a different setting there than I would for the east side of the building. With this system, you can, again, do an individual apartment, group them together for east side, west side, or do a global, which is the whole apartment. Either way, you can kind of play with that based on that property. And this just shows you a typical screenshot where you got on the left side, a tree. It's the building. It might be the building number 510, and in 510 is apartment 400, 401, 402, 403. And at any time, you can click on one of those individual apartments. Like here, we show apartment 409, and in 409, we have a thermostat. The second one down is in the bedroom, and then we got a thermostat in the living room, and so on and so forth. So very easy system to navigate as the building owner and to set up. You can go in and put in different parameters and schedules. Monday through Friday might be one schedule, weekends another, nighttime a different setting of temperatures. And this allows you very easily to do that. And this screen is showing really where we're bringing in the internal temperature as well as external temperature and degree days. So you can really do some very good analysis of where's it being wasted, where do I have issues within an apartment, and what's causing that. And you can do this just by clicking on and off the different boxes. And then you also have the ability to use a mobile app or online in our portal where the tenants can actually go and see a visualization of a thermostat in their apartment and can set it remotely. Gives them an ability to engage. We've seen kind of a mixed view here. Some of the market rate, more sophisticated buildings, the tenants are asking for this because it's kind of nest-like, for the lack of a better word, and they give it to them. A lot of property managers, especially in affordable and student housing, say, no way, I don't want to get phone calls from my tenants about this. They got the thermostat, they can go push the button up and down and call it a day. So it's really up to the owner, what he wants to do. He can either expose this to the tenants or not. It's really helps them. But ultimately, if you can get buy-in from your tenants, you might be able to achieve even better savings, because think about it. I can't go into an apartment, maybe I set the parameters of 70 to 75. Okay? I can never say in the winter, I can set it at 65 degrees, right? That's not fair. And that would never happen. But you might have some tenants that 70 is still too hot. So they'll take you below to 68 or 65 degrees. Okay, you just picked up savings. Same on the high side. So you want to put in those parameters, and in some cases, you allow them to go below or above, depending on the time of year. So if they do get that engagement from the tenants, you could get an incremental savings beyond what you could put in there. So I want to talk about a couple projects, because I find that helps. Let me just stop for a second. Any question from anybody on the phone? All right. I only see a couple. Yeah. Okay. Nothing to jot. All right. So when we look at a project, one of our larger ones, kind of unique, is in New York City on Roosevelt Island, which is in, right on the river there. 1,000-unit apartment, all electric heat. So what happened is the ownership group saw this and was having $5 million a year electric bills in the winter, because they had baseboard heaters in every apartment, multiple baseboard heaters with no control. They were basically either on or off, or old, weren't even working. And what the tenants tended to do, if they got too hot, they opened a window. It got too cold, they closed the window. That was their thermostat. We call it a double hung thermostat. In this case, they went in and retrofitted this building, and in multiple buildings, without a doubt, to cover 1,000 units, and put in 2,400 thermostats. So basically a thermostat in the bedroom and a thermostat in the living area, kind of in general. But in those apartments, they might have had 3 electric baseboard heaters. So we connected a relay, which we call a mini, M-I-N-I, to each one of those baseboard heaters to turn it on and off, based on thermostat settings. And what that did for them is reduce their energy usage by about 20% or higher, winter after winter after winter. Well received. Tenants were happy because they weren't overheated, but at the same time, they got the appropriate heat, not only that New York mandates, but also that the landlord provided. And in this case, the landlord really did it, started on a global basis. Here's the settings. But they knew that in this situation, there was quite a few, let's call them hallways, that were reserved for either the elderly, or they had some people with some kind of physical or mental disability. And they would provide additional heating in the winter for them, because they knew it'd be more comfortable. So they were able to not only do it on a global basis, but kind of did some customization based on the tenants that they knew were in those apartments. And what we did here is electric baseboard here. This you're not going to find everywhere, but it's definitely worth talking, because you'll just see the control opportunity. And put this little mini, which connected to the electric heater, would just turn it on off. And that was turned on and off based on the thermostat control. Huge savings within this property, without a doubt, from this type of system. So just keep that in mind if you run into electric baseboard type of solution. Another property is up in New Haven, Connecticut. This was brand new construction, 32-story building. It was the first platinum LEED apartment building in the United States. About, I don't know, 7 years ago, 8 years ago. In this case, they did multiple things. They put in water meters and electric meters to bill each tenant. They put in a what they have. Oh my gosh, drawing a blank. Some kind of thermal system throughout the building. And then they put in thermostats to control everything. And with this, these thermostats not only and mainly they were Yale graduate students, so it was really a market rate apartment. Just a lot of the people living there were from Yale graduates. The ability to control their apartments, get it set the way they want it, and huge savings, both on the water side as well as electric, as well as the HVAC. And what made this building unique was what I couldn't think about was a fuel cell system in there, which really helped lower their electric costs, but also the heating and air conditioning. So that's an example of a high-rise new construction. When you look at the one before, that was more of a 50-year-old building. Here's some student housing, which I'll be honest, you could just consider this just as much student housing as it is a new apartment. And they put in water meters and put some thermostat controls. This was down at the University of South Carolina. Pretty big property, 530 units. This here is a commercial building in Atlanta. This was new construction and kind of unique. It was mixed use. So you had, some retail spaces on the first floor, apartments, I think were the next, let's say 20 floors, and the top 20 were condos owned by individuals. So pretty unique. They wanted to bill each tenant for water, and we did that. But they also put in thermostat controls in the apartment. And this was the type of apartment building where the landlord used it as a marketing play with their tenants and gave them the mobile app to use in those apartments so they could remotely set their air conditioning and heating. That was down in Atlanta. Here's another apartment building at the University of Texas A&M. This was really a third party. It's not owned by Texas A&M. It's a third party apartment that they build right on the outside. And I'll be honest, I've put 3 kids through college, 4th one's finishing up, and some of their apartments had nicer granite than my house. So these are not your typical dorm room that you might remember. But they went in there and they put in the meters for electric, but also thermostat controls. And it was very important that they had those thermostats in there to control and take advantage of that vacant utility cost, both when it wasn't occupied, but more importantly, during those spring break, winter break type changes. And last one is kind of similar. This is an older building at Penn State, regular apartment. Just a lot of Penn State students, but here they put meters for the hot water, but also thermostat controls in the property. So with that, it gives you kind of an overview, right? We're going after conservation, we're going after maintenance issues, and we're going after safety, looking at why is an apartment exceeding or below a heating spec, which doesn't make sense. I think that's the last slide there. I must have not put in the final slide, but I'll go back here. So with that, let me open up to, if you guys want to unmute yourselves. If you got any questions for us, be happy to talk about your individual property. Go ahead. We got a couple minutes here.
Hey, Don, Dennis, Cody.
Hey, Dennis. How you doing? Yep, sure.
Yeah. Well, we finally got Valley Hospital to want to do something.
Very nice.
And we're looking at buildings that they're commercial, but they have a number of different restrooms that they like to be able to meter the toilets and the sinks. I'd like to be able to do leak detection in areas such as the water risers for the sprinkler system. Okay. And leak detection. They finally got smart when they had a leak in one facility on a Friday night that was undetected all weekend. It cost them $250,000 in repair. Now, of course, insurance paid part of that, but the insurance rate went sky high.
Sure.
So I'm going to be calling you in the next week or so because they're looking for a proposal.
Great. You know, in that case,
That case study for a commercial.
yeah,
Right.
yeah, we do a fair amount of, you know, either sensors on the floor to detect water or a rope sensor you could put around the riser pipe. And if water hits that at all, we'll send that alarm. You know, kind of similar to what we do with the air conditioning, right? Hey, if been calling for heat and never got there, send an alarm. But in this
Now
case,
they have
yeah,
a pulse heating system.
okay,
So I don't know how the thermostats could work,
Yeah.
but if we talk about it, that would be
Yeah.
something they'd be interested in too,
Yeah.
because getting control of the heat and especially individual suites is important to them.
yeah. But in this case, we'd focus on, like you said, the flooding, actual water, physical damage, and then we can shut off the water, right?
Yep.
Remotely. With, you know, water hits that riser on the outside, you know, there's water on the floor because you got some sensor, it can turn off the riser, and we can go anywhere from 3/4 inch up to 3 inches to shut off the valve automatically. And if it's beyond that, we can use a butterfly valve to actually do the turn off with the solenoid switch. So
Excellent.
good. Look forward to working with you on that.
I look forward to it. Thank you.
Good. Anybody else? Questions or comments? All right. Well, I know Susie Abbott from our marketing team is recording this, make it available to everybody. I think people that do attend will get a copy of this presentation. And with that, if there's no other questions, I think we are done.